Hello, today I want to talk about pose drivers in Unreal Engine. So let's begin. We need to create a pose asset. We cannot create a pose asset directly in Blender, but we can create an animation sequence in Blender, and then in Unreal Engine we can convert this animation sequence to a pose asset. Here I prepared a simple test sample. Right now there are no animations or anything else. It is just a skinned mesh. I have a sphere and I have this tube above the sphere. So I need to add the first neutral keyframe. I navigate to the first frame, select all bones and insert the keyframe. So it's our neutral position. Then I go to the second frame and start adjusting things. I move the sphere here and then adjust the other bones to make everything look natural. That looks okay, so we now select all bones and select the second keyframe. Then I create a few more poses. So now we have several different positions. For a better control over multiple animations, I changed the layout a bit. I switch from the timeline to dope sheet. Here's dope sheet. And to action editor. Then I split the layout. And here I select nonlinear animations. We can name this animation somehow like pose asset and push down. Now we have a new NLA strip with this animation. In our case, it is just a way to pack multiple animations into a single FBX file. Now I want to create another test animation. I can mute the first animation so it doesn't distract me while working on the other things. So I want to create animation which will affect only the driver bone. I click I to create the first keyframe, create keyframe somewhere here, and duplicate the first keyframe to complete the animation loop. Now we have these simple movements of the driver bone. Now, before export, I want to make sure that I understand the names of the bone. This bone is just named bone, but I want to make better name like sphere. Then we need to check the units. For Unreal Engine, we need to have a metric unit system and we need to have unit scale of 0.01. After setting units, we need to check the dimensions. It should be valid for object you are creating. It is not very important for animations, but it is important for physics and other things. Then I select both objects, so the mesh is selected and the armature is selected, go to export, FBX, then selected only, Y forward, Z up, it's important to set, then smoothing should be set to face. Under armature, leaf bones should be disabled, and here under animation we need to keep one of these things only. So I choose to keep only actions, so I disable NLA strips. Otherwise, if you enable both of them, and they are both enabled by default, you will get duplicated animations in Unreal Engine. So that's why you only need to leave one of these options, NLA strips or all actions. Now let's go to Unreal Engine. It is one of my test projects, and we need to import the FBX file we just exported. We need to make sure that the skeleton is correct. In my case, I don't have anything similar in the project, so in my case, I need to have none here to create a skeleton from scratch. So now we have physics asset, we have skeleton, we have skeletal mesh, and we have two animations. It is better to rename everything. Now we need to create a pose asset. I open the skeletal mesh, go to animation tab, select this pose asset animation, click create asset, create pose asset from current animation, and I will create animation Now we have 5 poses. The neutral pose here, the neutral pose at the end. The neutral pose, I mean, it doesn't stretch the tube. And we have the other stages of the animation. So to use it in animations, we need to create animation blueprint for it. Let me go to skeleton, right click, create animation blueprint, ABP underscore. Now, also it is good to rename the poses. And now we can save the asset and go to our animation blueprint. In here, I need to create a PoseDriver node, and we need to set a few things first. Before we proceed, we need to set a few important things. We need to say which bone will drive. It is source bones. We need to add element and set which bone will drive. In our case, we want to bind the movement of other bones to the movement of the sphere. So I click sphere, and it's important to set under settings, drag and drop the pose asset. After this, we can click here tools and copy all from pose assets. It's important to copy all from pose asset only after setting the source bone, because otherwise it will not work properly. So you need to set pose asset, you need to set source bones, and only then you need to copy everything from pose asset. Now we need to set the type of transforms we are going to read, because the sphere will move up and down, so it is not rotating, it is only translating. So in our case, rotation means nothing. So that's why we need to go with translation. And to see how it works, I will add test animation. As you remember, this test animation only translate the source bone. So I connect it in here and I enable looping for this animation. Right now, as we see, it does nothing right now. So we need to continue. We need to set which bones will be affected by the movement of the source bone. By default, all bones will be affected by the PoseDriver, but we can actually set them one by one. And now we can set the radius. Under RBF params, we can set the radius. And you can see it is visualized in the preview. It defines the area of influence for each pose. You can increase the radius to create more overlap between poses, and it gives some smoother blending, or you can make the transitions a bit sharper. Another important parameter is solver type. By default, it is set to additive, which is faster. The interpolative solver is described in the documentation as more accurate, but also slower. I recommend trying both. And since they handle radius differently, it's good to find a good radius for one solver, then switch to the other solver and adjust the radius again. And after that, you can decide which one works better for your case. And also, if you want to change the influence of a specific pose, you can go to the top and expand any of the poses and change its scale. For interpolative method, it is adjust a weight coefficient, while for additive method, we can visually see that the size of the shape actually is changed, so it defines how this pose will react to the transforms of the driver of the source bone. At this point, everything works using a hard-coded animation, but we can make it work as a post-process animation blueprint. To do so, I replace the test animation with input pose node. Then I go to the skeletal mesh, and under asset details, I need to find post-process anim blueprint. Here's our blueprint. And now that's it. Even here in the editor, I can actually move the sphere, and it will react to the movement of the sphere. So now the correction work in real time, and they are applied on top of any animation. Even when I move a bone directly in the editor, the post-process animation blueprint automatically adjusts the driven bones. So thank you for watching, and see you next time.